Good day everyone, this is Decadetya Enrico and today I am going to demonstrate to you on how to find the initial course, final course, and the position of the vertex using great circle sailing. So let's get started.
So this is the problem and the solution. I have written it already so that my video will not be that long. So find the distance along the great circle, initial course, final course, and position of the vertex when sailing from 33 degrees 50 minutes south, 023 degrees 12 minutes east to 20 degrees 10 minutes south and 104 degrees 00 minutes longitude east. Also find the latitude in the great circle crosses in 40 degrees east to 70 degrees east long. Verify initial course and final course by the ABC tables. So I have here the given and my illustration. So the given is position A, which is here. The position A is latitude of 33 degrees 50 minutes south and longitude of 23 degrees 12 minutes east. The position B, or position of arrival, is latitude of 20 degrees and 10 minutes south and longitude 104 degrees 00 minutes east. So to get we have to find the difference of longitude. So the difference of longitude is the higher value subtracted by the lower value. So the longitude A or the longitude B subtracted by the longitude A, because in our scenario the longitude B is the highest. So we should get our calculator. Longitude B, which is 104 degrees 00 minutes, subtracted by longitude A, which is 23 degrees 12 minutes. The result is the difference of longitude is 08080 degrees 48 minutes and the direction is east. You wonder why it is added or subtracted, because if it is in the same direction it will be subtracted, and if in different direction it will be added. So now we have here on how to solve the distance. So again, we should write the given so that we will be guided. So the given is latitude A. We need the latitude A, which is 33 degrees 50 minutes south, and the latitude B, which is 20 degrees and 10 minutes south. And again, we need the difference of longitude, which is 080 degrees 48 minutes east. So now we have to find the value of the PA, since it is needed here in our formula to get the distance. So the PA, since the PA is, note here, we have a note here, PA is same hemisphere, so 90 degrees subtracted by the latitude A, because it is in the same hemisphere. The A is in the southern hemisphere and the P is also in southern hemisphere, so both are in southern hemisphere. So we should do this 90 degrees subtracted by the latitude A. So 90 degrees subtracted by latitude A, which is, our latitude A is 33 degrees 50 minutes. So we're able to come up with PA is equals to 56 degrees and 11 and 10 minutes. So same procedure in getting the PB. So the PB here, or the arc of the pole to position B, which is, they are also both in the same hemisphere, because the position B is, the position of arrival is in southern hemisphere and the pole is in southern hemisphere also. So we should do this again. 90 degrees subtracted by latitude B, which is 20 degrees 10 minutes. We are able to come up with this answer, which is arc of PB is equals to 69 degrees and 50 minutes. Now, to solve for the distance AB from position A to position B, the distance between these coordinates. So here is the formula that I use. We have two formula. We have two formula to be. We have two formula to be used, which is the Mark St. Hilaire formula, but I chose this formula. So the formula is cosine AB, or the distance of AB, is equals to cosine P, which is the pole, times the sine PB, or the arc PB, times the sine PA, the arc PA, plus cosine PB and multiply by cosine PA. So now we should substitute our value, since we have this all in given. So the cosine P, which is the D long, the P here is the D long. This part here in the triangle is the D long. So cosine P, which is the D long, is equals to cosine 080 degrees 48 minutes east, multiply the sine PA, which is 69 PA, PB, which is 69 degrees 50 minutes, and multiply again to sine PA, which is 56 degrees 10 minutes, plus the cosine of PB, which is 69 degrees 50 minutes, and multiply to the cosine of PA, which is 56 degrees and 10 minutes. So we should get our calculator. So parenthesis cosine 080 degrees 48 minutes, 080 degrees 48 minutes times the sine of 69 degrees 50 minutes, again multiply again to the sine of 56 degrees 10 minutes, close parenthesis, addition, again parenthesis, cosine 69 degrees 50 minutes, multiply to the cosine of 56 degrees 10 minutes, in close parenthesis. We are able to arrive at this type of answer, which is 0.316615862. So to get the value of AB, we should transpose or inverse cosine. So from this value 0.3166115,862, we should go to shift and cosine to get the inverse cosine in our calculator, and press equal. So the value is in degree form, which is 71 degrees 32.5 minutes. To convert this into miles, we should multiply the degree by 60. So we are able to come up with a distance from A, B at a distance of 4,292.5 miles. Now, to solve for the initial course, which is the course between point A to point B, this course here, or this angle here. So we have here, again, we need to write the given to be guided. So we have solved it earlier. The PB is 69 degrees 50 minutes and the PA is 56 degrees 10 minutes. And the distance of AB, which we have been solved already, is equals to 71 degrees 32.5 minutes. So the formula in solving for the initial course is cosine A is equals to cosine PB subtracted by cosine PA times cosine AB divided by sine PA multiplied by sine AB. So we already have this value, so we just need to substitute. So using our calculator, open parenthesis, operate this equation. Cosine 69 degrees 15 minutes, which is the PB, subtracted by cosine 56 degrees 10 minutes, which is the PA, multiplied by cosine 71 degrees 32.5 minutes, which is the distance that have been solved. Close parenthesis, divided by, open parenthesis again, sine 56 degrees 10 minutes multiplied by sine 71 degrees 32.5 minutes, which is the distance. So equals, we are able to arrive with this answer, which is 0.213811288 degrees. So to get the value of the A, we should go for inverse cosine or shift cosine in our calculator with this value and press equals, and it will automatically give you the answer, and press in degree form, which we haven't arrived in. The initial course A is equals to south because the direction of the A is in south, and east because the course is going to east direction. So that's why we have south 77 degrees 39.25 minutes east. Note, to find the true course, I have here a diagram. So north, east, southwest. So if in northeast, it will remain, and if in southeast, it will be 180 will be subtracted to the value of the course, and if it is southwest, the course will be added by 180, and if it is northwest, the course will be subtracted to 360. So in our case, our course is southeast, which is here, so we need to subtract it by 180 to get the true course. So 180 subtracted by 77 degrees 39.25 degrees is equals to 102 degrees 20.6 minutes in true course. Now we will move to our final course. So our final course, now to find for the final course, we should reciprocal of the B, or reciprocal of the value of the course. Okay, so again, I have here the given, but we will be going direct to the formula. So the formula is cosine B, which is here, because we need to find the final course from this point to this point. So it will be reversed. So cosine B is equals to cosine PA, which is 56 degrees 10 minutes subtracted by cosine PB, which is 69 degrees 50 minutes multiplied by our cosine AB, which is 71 degrees 32.5 minutes. divided by sine PB, which is 69 degrees 50 minutes, multiplied by sine AB, which is 71 degrees 32.5 minutes. So we will operate this equation in our calculator. So close parenthesis, cosine 56 degrees 10 minutes subtracted by cosine 69 degrees 50 minutes multiplied by cosine 71 degrees 32.5 minutes, close parenthesis, divided by open parenthesis sine 69 degrees 50 minutes times sine 71 degrees 32.5 minutes. We are able to arrive at this value. So again, to get the value of B, we should go for inverse cosine or shift cosine in our calculator, and it will automatically give the value of 59 degrees 49.2 minutes. So our direction here is southwest because our the location or the direction of the B is in south and the course is going to the west, so it will be southwest. Note that to find the final course, it will be reciprocal of the B. So example, so the final course is 59 degrees 49.2 west. So assuming that it is somewhere in here, so the reciprocal of this course is this one, is this course. So the reciprocal now will be, you only need to change the direction, which is in northeast. So north 59 degrees 49.2 minutes east. That will be our final course. Now, this is the tricky part, the position of the vertex using the Napier's rule. So I have here this figure which I have drawn and numbered to be guided us on where to put the position or the location of each point in the Napier's rule. So I have here the vertex, and the number 2 is the arc of the VA, and the number 3 is the angle A, which is 77 degrees 39.5 minutes, which we haven't solved earlier. And the PA here, since I have explained it earlier that we need to subtract it by 90 degrees since they are in the same hemisphere. So 90 degrees subtracted by 33 minutes, which result to 56 degrees 10 minutes, and the P here is 080 degrees 48 minutes east, which is our D long earlier, and the arc PV here is this one. So now this is our triangle. This is the coordinate. This is the point A, and this is the point B. From point A to point B, and AB is the distance and PB is the arc. We have solved it earlier, and the arc of the PA also, and the difference of longitude which is the P, which is the value here. Now this is the formula in solving for the PB. For the PV, since we don't have this value, we need to solve it. So the formula is sine PV equals to sine A multiplied by sine PA. So we have the value of sine A is equals to, get our calculator, sine A is equals to 77 degrees 39.5 and multiply to sine PA, which is the value of 56 degrees, sine PA 56 degrees 10 minutes. Again, okay, sine 77 degrees 0.39 77 degrees 39.5 minutes multiplied by sine 56 degrees 10 minutes. So I have here, I arrive at this value. So again, to get the value of the PV, we should go for inverse cosine or shift, inverse sine or shift sine in our calculator. So we arrive at this value. So press in degree form. So the value of the PV or the arc of the PV is 54 degrees 14.36 minutes. Now, we need to solve for the latitude of the vertex to get the position of the vertex. So the latitude of the vertex is equals to 90 degrees plus minus PV. So if they are in the same the same hemisphere, we should go for the addition. But if they are in different direction, if the P and the B is in the same hemisphere, we should go for subtraction. But if the P and the V are in different hemisphere, we should go for addition of 90 degrees. So again, 90 degrees subtracted by 54 degrees, since they are in the same hemisphere, we arrive at this value, which is 35 degrees 45.64 minutes south. This is now our latitude. Now we need to look for the longitude to have the position of the vertex. So the formula in looking for the longitude, which is tan P is equals to 1 or the reverse, but in simple form we just need this equation. So 1 divided by tangent A multiplied to cosine PA, which is tangent A is equals to 77 degrees 39.5 minutes, and tan cosine PA is 56 degrees and 10 minutes. So we should operate this in our calculator. 1 divided by tangent 77 degrees 39.5 minutes multiplied by cosine 56 degrees 10 minutes, close parenthesis. So we arrive at this value, which is the value of 0.392969537. Again, to get the value of the P, we should go for inverse cosine or shift, inverse tangent, which is shift tangent in our calculator. So the value of the P or the longitude of the vertex, the difference of longitude of the vertex is 21 degrees 27.2 minutes east. Now this is the difference of longitude, so we need to get the value of the longitude of the vertex, the exact value of the longitude of the vertex. So the formula is equals to AB, since AB is here, so it will be subtracted by PA to get the value of the vertex. So AB subtracted by the value of the PA, which is 71 degrees 32.5 minutes subtracted by 56 degrees 10 minutes. Now we arrive at the value of the longitude of vertex is equals to 15 degrees 22.5 minutes east. Now we have the longitude and the latitude. We have the latitude and the longitude of the vertex. So this is the position of the vertex in the given problem or equation. Position of the vertex is in latitude 35 degrees 45.64 minutes south, and in longitude 15 degrees 22.5 minutes east. So that's it for the Great Circle Sailing. I hope you learned something. Thank you and God bless. This is Deck Cadet Yaon Rico. Bye-bye.